Hello, Augies and electronics enthusiasts the world around. I'm Dave Casler, amateur radio call sign KE0OG, coming to you today from Ridgway, Colorado. Welcome to another episode of Ask Dave. In this one, we're going to review a little QRP radio. These seem to be all the rage these days. There's quite a few available from a variety of different manufacturers. This is the CFT1 5-band CW Field Transceiver, and it's this little thing right here, a sandwich, which you can see here. There's two circuit boards, these internal ones, a cover, and so on. This is serial number 3. So we're going to take a look at this. I did a fair amount of research on it. Nice little radio. I mean, it works. It came to me assembled. I printed out the manual for it. This is a pretty good manual. I like it. Covers all the features in a very straightforward way, all the messages and so on. It is an entirely analog radio. It has quite a few features. Let's take a look at a few charts that I put together on this. The radio is available from an outfit called Ham Gadgets right here, and they've got a number of things available. This is the one that it comes as built. Now you can also get it in a kit version and save $80, which is a pretty significant fraction of the cost. And here is the unit right here. We'll go into a lot more detail about it. Took this picture yesterday, and it says in stock. Bit on the pricey side at $400 compared to some of the ones that are available from overseas. But the problem these days, of course, are the tariffs, which can make a less expensive overseas product suddenly more expensive. Okay. This is what the radio looks like. We have an input. You can take between 8 and 14 volts. None of this namby-pamby nonsense about 9 volts exactly or 12 volts exactly or something like that. In other words, this will fit in a normal ham station or a normal ham's battery. Audio is out. These are the earphones. The paddle is for the key. Note that a straight key can also work. You have to set the menu for it. Volume control, tune control. By pressing a short press, you get this little underline right here that moves out between these, so you can set the step at which you would like to tune. If you press it long term, you get the RIT, the receiver incremental tuning. And now you've got some buttons over here. This one right here, if you give it a short press, it changes to bands. It cycles from 7 through 15 meters, catching all the bands in between. And if you long press it, it's XIT, XIT, which is the transmit incremental tuning. So you can transmit above or below the frequency of the other person. The menu is right here. You press the menu, you use the tuning knob to go between menu items, and you press the tuning knob to pick up that particular menu item. There are 4 keyer memories which can be preset in the menu, M1, M2, M3, M4. If you want, you just press the button once. If you hold it down, it will repeat as per the instructions you've given it. Over here is the output. It's a BNC connector, not my favorite for radios. All my station antennas and stuff are PL259, so I've got to put an adapter on there. There is actually an on-off switch here, which is a kind of a nice little feature. Speaking of features, let's take a look. With 5 bands, okay, CW only, built-in keyer, or you can use a straight key. Now there is no spotting function, so you can't easily line up what you're going to send with the station that's coming in. Also, there's no CWD code. CWD code seems to be kind of popular on some of these smaller radios and, of course, the bigger radios. CWD code's not always very accurate unless you're decoding machine-sent code. It does have receiver incremental tuning and transmitter incremental tuning. Memory keyer, 4 memories times 40 characters. So for example, one of them can be your CQ, and you can put that on repeat until somebody answers. There is a beacon mode for CW. I didn't explore that. Now the power levels vary significantly between the bands. 40 and 20 are the highest. I'll get into that in the testing. It'll take 18 to 14 volts, about 2 amps on transmit, much less on receive. And you might as well just leave the backlight on because it takes very little power for the backlight. BNC, headphone paddle connections. These are the items in the menu. CW speed, the keyer mode, which would be iambic A, iambic B, and straight key. Use iambic B, bravo, if you are using a paddle. CW pitch is the offset. Normal these days is about 700 hertz, and I think that's the default. The paddle direction, you can either go left, right, right, left. It'll switch it if for some reason yours is wired backwards, and DITs give you DAWs, and DAWs give you DITs, etc. Your CW messages, the beacon interval, a beacon timeout, and a backlight. I like the two knob way of doing things. It just makes it easier. You get a little view of the side. It is fairly thick. Here's your BNC connector and the on-off switch. Here's all your little buttons and so on. This is the back of the radio. We're taking it apart now, so that I'm taking it apart so you don't have to. Serial number 3, so pretty early one. This is a metal plate, I believe, and this right here screws into the final output transistor, which uses this entire back plate as a heatsink. Here's the upper side of the back plate. This piece of white here is supposed to help the thermal transfer to the plate itself. These are 3D printed separators. Be careful with them. It is possible to break them. You don't want to do that. This particular is the other one. Note this rather thin piece right here, which can break easily. So don't break those as you're assembling your kit. This is the top piece, of course. This is underneath the top piece. And you see the volume controls and everything. These set easily. I like the two because you normally have one set for volume and one set for the frequency. Note that this display is held in place by 2 screws. And this one right here works against the distance put here. I'm not even sure they really need this one. This one right here is a little different. You can get yourself in trouble with this. Note that there is no spacer. And if you pull down too hard on that, you'll bend the board, which you don't want to do. Now here is the nut on the other side. The nut is held up against this connector here, which connects the 2 boards. The problem is that this is anything but tight. And if this were to come apart, you'd have this nut wandering loose in the schematic. Would be a very, very bad thing to do. You can see it right here where the nut is right here. Here's the nut for the other one. This is tight enough, but what I did was take some fingernail polish and put it all over this nut here to keep that screw from turning with vibration and use and so on. And I did that same thing with the other one also, so that they would not turn, because neither of them are very tight, and I don't want a nut running around inside this thing. Okay, here is the underside of the main RF board. I don't know what that is. It could be a cat, it could be a bear, not sure. Anyway, the CW down here says WOW. Wow. This is the actual RF board. I want you to notice a couple things. There is a 4-pole filter in the IF of the device. These are relays for switching in the correct amount of inductance in the output, and there are some capacitors attached to the various filters and so on. This right here in the middle, this is where the screw comes through from the other side, and it's the heatsink. It uses the entire bottom element. So I used a little heatsink goop that I had left over from when I built a computer just to give it a slightly better thermal platform. And these are various screws. The black ones actually go in the bottom, the silver one's in the top. You would have thought it was the other way around, but since it's a black case. These right here, and there are some other types of extenders too. You've got to put them in the right order. After I'd taken it apart, I had to actually go look at the build manual online to make sure that the thing was properly put together. Now, I want to talk about some testing I did, and I want to show this requirement. This is in the FCC regulations, Part 97.307 Delta. It says for transmitters installed after January 1st, 2003, the mean power of any spurious emission from a station transmitting or external RF amplifier transmitting on a frequency below 30 Hz must be, and I put this in red, 43 dB below the mean power of the fundamental emission. Why might I be showing you this? Because the radio has some issues with that. Here, let's take a look at 40 meters. This is my oscilloscope. This is my spectrum analyzer. The voltage happens to be that one right there, the RMS voltage. It's hidden a little bit under the frequency counter. With a VRMS of 21.7 across 50 ohm load, that gives us a power out of 9.4 watts, which is pretty good. That's actually a little higher than what is generally considered QRP, but it'll do. Now, here's your signal. Note all the harmonics. Now, if you take the signal, now these are all relative because I had to use a big attenuator in here. This is 0 dBm at the top, obviously. I just told you that it put out 10 watts. 10 watts is 40 dBm, okay? So I've got it taken down here to the point where we see the top at around minus 12 dBm. Again, this is relative to each other because I use that attenuator. The second harmonic is minus 47. I'm eyeballing 47 dBm. So the suppression of the harmonics is 35 dB, which does not meet requirements. It's off by quite a bit. We were looking for 43 and we're getting 35. Now, if you look at these, 35 dB is 1/1000th approximately. So you're not losing a lot of power in these spurs, but it does put a signal out. Just for kicks, I put key down on this and was able to listen to this on my radio very clear. So this is 30 meters. 30 meters puts out 4.2 watts. The signal is suppressed by 41 dB. It's real close to the requirement, okay? 20 meters, we have 5.5 watts output. This is into a 50 ohm load using the RMS reading right there, 16.6. Okay, and the suppression of this first harmonic is 48 dB, and that definitely meets requirements. On 17, we're down to 3.8 watts. Second harmonic right here, suppression 55 dB, meets requirements handily. And 15 meters here, 3.1 watts. And the suppression of 52, which meets requirements quite handily. Now, some final observations here. You need to go to the website to download the manual. The way that you do that is you go to Google and Google KM4CFT, and the top website will be his website, his commercial website where he sells things. Now, if you go to that, you can download the manual, and you will definitely want to do this. Now, there is no way to upgrade the firmware. Mine is 1.10.5. It works, okay? But there's no way to upgrade it. You can't connect a USB cable to this or anything like that like you can on some other radios. 8 to 14 volts is nice. There's none of this namby-pamby 9 volt only. And there's a power pole already connected to the supply cord. It's available kit or finished. Mine came finished. A nice 20-page user manual. Now the construction manual, which is much longer, uses the same technique as QRP Labs, which means it's an excellent construction manual. What QRP Labs does, it's for every step, it's got a photograph of the board with the thing outlined, what you are doing in that step. Has a nice CW receiver, about 500 hertz bandwidth. There is no way to zero beat unless you perfect pitch or something like that. I would suggest you just leave the backlight on as it consumes very little power. So there you have it. It's a nice little radio, something that you can take with you on a QRP trip. It's very solidly built. It's not going to come apart or anything like that. Of course, all of them are pretty well built these days. So I would say that it's great. The price is about $100 to $150 more than I think I would want to pay. But like I said, these other radios are coming from abroad and are subject to tariffs, so that can be an issue. So there are ways to support this channel that come up after the 73, and so I'll let you get to those and say 73.